Thank you. Thanks, Bob. So as Bob mentioned, then I have 2 degrees in geology, and we'll talk about how geology plays a role in water in just a minute. So first of all, I guess the first question is, what is the study of geology? What do geologists study? Right, so study of the earth, exactly. And so yeah, way to go. And so that's what I did my studies in. And then I also did an emphasis in water and water quality. So I also looked at what are some of the things in our drinking water, for example. So those are my kind of specialties. And then through my position at the county, I got into water conservation and how it affects us as a whole. And so let me see if this thing works. Oh, okay. So since water quality and water geochemistry and those types of things are my emphasis, we're going to talk about a little bit of chemistry. So the properties of water, it's chemically known as H2O. So what does the H stand for? Hydrogen. And what does the O stand for? Oxygen. And how many hydrogens and how many oxygens do we have? 2 what? 2 hydrogens and 1 oxygen. Okay, so it's the only molecule that's a solid, a liquid, and a gas. So what's the boiling point of water? So we actually, since we got down to we had a freeze the other night, or kind of, at my house it was a freeze. What's the freezing point of water? Well, not negative, just 32 degrees. The boiling point of water is 100 degrees. So a little bit of a fact, or tidbit, is the earth does not receive any new water at all whatsoever. So all the water that it has on the earth, that's all we're ever going to get. There are 2 exceptions. One exception is we may receive some water through meteorites. So water from other planets, and some scientists believe that that's how life on our planet began. And another way we might receive new water, but this is a very, very minuscule amount, is through volcanic eruptions. So those are a couple of ways. But other than that, what we've got is all we've got. Oops. So the hydrologic cycle. Again, this relates back to all the water. This is all the water that we have. So let's go through some terms. Precipitation is also known as rain. Yeah. So there's precipitation, and then there's infiltration, which is right here, and that's water that percolates through the Earth's surface, and then that water is groundwater. And it can come out through springs, through seeps, and it can discharge in fresh water, in rivers and also into the ocean. Evaporation is what? So when a water turns to a gas. Yeah. Well, liquid, yeah, I gotcha. Sometimes I just say, you know what I'm saying? And they do. So it's one of those moments. I know what you're saying. Evaporation, we have that, and we have condensation. So what about condensation? Exactly. So it goes from a vapor into a liquid. What about sublimation? Sublimation. So there are 3, remember that 3 phases of water. So we have a liquid, and we have a liquid that goes into a gas, which is evaporation, and then condensation is the gas goes into a liquid. And what's our last phase of water? It would be nice in my glass right now. Ice, right. Okay, so sublimation is when you have snow or ice and it goes directly to vapor. So, I should be going down. So all of the water on Earth. So we have 99% of the water that we have on Earth is in the ocean. 1% of that water is fresh water, and that's the water that we use. And out of that fresh water, 69% is in glaciers, Around 30% is in groundwater, and 0.3 is in lakes and rivers, so surface water. And you can see the little diagram kind of demonstrates. So we've got this pie graph of only one little minute sliver is what we could actually use, we as humans. And then of that, you know, a larger portion is groundwater, and then the rest is surface water. Okay. So fresh water can be known as potable water, and that's the water that's drinkable. And less than 1% is available for use. So water withdrawals in 2000, according to the U.S. Geological Survey, were, 21% of groundwater and then 79% of surface water, which I think is interesting because we only have this 0.3% of surface water that we can use in lakes and rivers, yet those are where most of our withdrawals are coming from. So I think that's a really interesting point. And so we look again at the middle graph, is that the surface water withdrawals, of those, 19% are saline and 81% are fresh. So the saline ones, obviously we can't use those. Those aren't really usable. There are desalinization plants that have happened, and one that's really been in the news lately, or the news that I look at, the water-related news, I guess you guys don't really look at that kind of news, but is in San Diego. So San Diego has created this huge desalinization plant. So they're pulling water from the ocean. They're taking all the salt out, and they're creating fresh water, and they're putting the salt back in the ocean. So then now we look at our groundwater withdrawals. So I think that's 1% is saline and 99% is fresh. And remember, we have a little bit more groundwater than surface water, according to the studies that the USGS has provided. So some terms for groundwater is water table, and these are terms that you'll see a lot in, again, if you read the paper, or maybe when I read the paper, these are the things I see. So water table is the top of the surface where groundwater occurs. So we're talking about below the Earth's surface. All of a sudden, if you drill a well, for example, it'll be dry, and then you'll have some moisture. So that is kind of where the water table is. Aquifer is used to describe water-bearing rock formations capable of yielding enough water to supply people's needs. So I didn't change the definition. I could have shortened it, but I wanted to make sure that we got in there that it's an entire rock formation, and a rock formation would be, for example, sandstone is a really good container of groundwater, and to supply people's uses. So there is water in rocks that we can't use. Hello. Okay, true or false? Are aquifers underground rivers and lakes? So what is your impression of an aquifer? Or have you ever heard that term before? Yes. So what do you think? Yes, no, maybe? You're not a gambling group, so you don't want to take that, your odds are stacked against you? Well, see, that's the thing, is that for example, and his question was, do aquifers get as big as a pond? The thing is that the media, and I've read this in the actual New Mexican, they actually depict an aquifer as like a big underground cave full of water, and that's not the case. What happens is you have basically rock, or you have sand, and then you have water that infiltrates in between those little pore spaces. So, all sand particles are round, and you've got some space in between them. So sort of like what's in our diagram. So you've got some rock, but then you've got water in between them. So it's not really this huge cave, because that's the things when I read them, I'm like, oh no, I can't believe they put that in there, because that's not the case. And so, for example, like you could see where they've got the water table right here, and then below the water table, there's the blue water, which is kind of hard to see against this background, but which is called saturated. So these pore spaces, which are the spaces in between the rocks, are saturated, so they've got water in them. And above that, it's just air. Let's see. So wells. And this is where the geology comes into play, because most of the times, you know, a geologist would be consulted on like where to place a well, or you know, is this a good rock bearing unit that has an aquifer unit or something like that. So this is just kind of a diagram of how we're placing a well, and you've got things like unconfined aquifer, confined aquifer, you know, confining beds. So it can get really complicated. So you need someone who kind of understands what's happening in order, before you drill or before you do anything, you know, that costs a lot of money pretty much, because wells can be very expensive. And in our area, it's even so much more complex than this, because we have things like faults. You know what faults are? That's where rock moves against each other. So we have faults, and we've got these, the sangres are a good example. That's a huge granite outcrop, which means that there's no water in that at all. So, and that could be really troublesome for well drillers. Okay, so now focusing on New Mexico. According to the Office of the State Engineer, which is the office that regulates where our, like what happens to our water, we have 53% of surface water withdrawals in New Mexico, and then we have 46% of groundwater withdrawals in New Mexico. So here are some withdrawals. I think this first map of the U.S. is surface water withdrawals, and so you can see New Mexico, and we're in that greater than 0 to 2,000, and that's a million gallons per day. So we're somewhere in the, you know, we're I guess less than 2,000 million gallons per day. And then for our groundwater withdrawals, we're still in that same category. But look at other states. You know, for example, those heavily populated states are the states that are obviously the darker colors, so Texas and California. So those are two that potentially, eventually, because they have more population, they could be looking for water from other places, and those other places might be the surrounding states that aren't using what they could possibly use. So for example, if we're only using less than our 2,000 million gallons a day, then maybe California might want some of those, and those could be potential issues that come up later on. So here's our water use, and that less than 1%, remember we only have 1% on the earth, and it needs to go a really long way. So just for New Mexico, our public water supply, and that's where, that would be water utilities, places where you pay your bill, those types of things, they count for around 8%. The self-supplied domestic wells, so we're talking about the, you know, if you've got a well at your house, I have one at mine, so those are roughly around a little bit less than 1%. Irrigated agriculture. So look at irrigated agriculture compared to all of these numbers. So it's a huge amount. So we're roughly 78% on our agriculture. Livestock's 1.5, commercial about 1, industrial a little bit, about 0.5%, mining 1.5, power 1.6. So evaporation from our reservoirs is 7%. So I think that was pretty interesting, because that's water that we have no control over, and it's going to be lost to the atmosphere no matter what we do. And that's a large number, 7%, compared to, you know, you think of commercial. When you look at Albuquerque, you know, that's relatively all commercial. So, and residential, but you know, you can see along I-25 and I-40, there are a lot of people using water, and then compare that to the evaporation. Okay, so focusing on Santa Fe. So do you have any idea where your water comes from? So the three, I guess, potential sources could be a public water supply. So for example, the city of Santa Fe, if you know, you get a water bill, or the county has its own municipality. Domestic wells, or community water systems. So for example, El Dorado has their own water system. And how much is the water? How much is the water really worth? And when you ask how much is the water really worth, whenever it's the source of all life on our planet. So let's discuss that for a moment. So what do you think water is really worth? Actually, El Dorado has one of the highest rates in the entire state.
Well, because we're in California, and
so That's really interesting. Remember what I was just saying earlier about how California might be looking for other places, and one of the things they've probably implemented is going through and having higher rate structures. So the more water you use, the more you're going to pay. And whereas, oh, you have a shared well. Well, yeah, oh, okay. So in El Dorado, there are shared wells, and then there is the main community water system. And I'm on a shared well myself, so we pay like $150 a year or something like that. Right, no, it's not. I mean, but when you consider, you know, you incorporated that into the cost of the lot and those types of things that you purchased, then it does get incorporated. But over the long term, $150 really doesn't make that much of a difference. So, so what about to fish? What is the water worth to a fish? Huh? It's priceless. Okay? So that's something to think about too. I mean, if our bodies are made up of 80% water, then water is pretty important to us. Do you think that we should charge for water? I mean, if we all have to have it, should we have to charge for it? But how do we supply money, or how do we get money to pay for the infrastructure? For example, you know, how do we pay for someone to bring it out of our tap? You know, it comes right there. Yeah, maintain it, those types of things. So, and yeah, cleaning the water, for example, too, because there are naturally occurring contaminants, especially here. Uranium is one. Here in Santa Fe County, arsenic as well. So you don't want to be drinking those things, but someone's got to clean it. I mean, could we all clean it ourselves?
Do you think maybe instead we should find people who pollute it, for example, big corporations, et cetera?
I think that might be one source. So what you're saying is that if they've overused their water and they've misused their water, so it's being a good steward of water, they haven't done that, then maybe they should actually pay more for it. I think that might be something to consider. So, but then it goes into who enacts that. So would that be on a local level, or would that be on a state level, or would it be on a federal level? So there are many layers associated with that. And then what happens when the corporation says, well, we're paying already really good money for it, why do we have to pay more? So those are just some things to think about. Okay, so talking about precipitation. Basically in the Santa Fe area we have about 14 inches of rainfall, and we've been in drought conditions on and off since 2000. And this is from 2005, and you can see the orange is a moderate, where Santa Fe County is, the orange is a moderate designation that's been given by the NRCS, which is the Natural Resource Conservation Service, I think. And so orange is pretty moderate, which means that it's started to get dry because we're only one down from emergency or severe. So, and a drought is when you have less than rainfall than you expected over an extended period of time, and usually several months or longer, and drought are a normal part of the climate. So if you look at the geologic record or the biologic record through tree ring dating and other things like carbon dating, and you can look at the glaciers, they have a signature as well. You could see those scientists, the glaciologists and those types of folks can look and tell that drought has occurred throughout the earth for several it's happened before in the past, pretty much. Okay, so in Santa Fe, looking at the 2000 census, we have, let's see, in the county, there's roughly 130,000 people in 2000, and then there's around 62,000 in the city. So then we've grown a little bit from in 2007, so we've increased 13,000 people, myself included, because in 2000, I didn't live here, and I moved in 2005 or 2004. So if we keep going on this rate, will there be enough water for everyone? We're all going to die. I don't know about that, but so should we prioritize, who gets what water? There's already a system like that set up in place, and it's through our water rights, I guess, legislation or laws. And it's called prior appropriation, so it means first in time, first in right. So the people that were first in time here in New Mexico are our native population. So the tribal entities, they have senior water rights. And then the other folks go down to like acequias, so they've been here for a while and they have older water rights. And municipalities like the city and the county don't have as senior rights as what they would like. So again, will there be enough water for everyone? How many people do we think we're going to have? What's our population going to be in the future? Okay, so there is a solution. It's a small solution, and if one person takes, one step at it, maybe it might not be that great. But if a lot of people take a step, move in the right direction, then yeah, it could probably happen. So through water conservation. So in Santa Fe, water use is about 50 to 75 gallons per day. So did you all know that you used 50 to 75 gallons per day? No? So it's looking at things like, shower, everything we use water for, drinking, showering, cooking, bathing, washing our clothes and our dishes. And then also there's a little bit incorporated in there for irrigation purposes or for, watering our vegetation. So our water usage can be cut by 10 to 20% without affecting the user's lifestyle. And they're through little changes. So what are some of the ways that we can save water? Yeah, that's one example. But then that has to come from somewhere, so are we...
In like the 1968, they had the a slogan, and there's like, save water. Save water.
Oh, right. Huh? Oh, less showers. There you go. That is that's one example that my husband actually follows. So he's on the less shower, less frequently schedule. And, not that I'm advocating that because it's not that fun for me. So, Bob?
I'm curious, your figure, you say Santa Fe water use is 50 to 75 gallons per person daily?
Uh-huh.
Is that the total use by the city of Santa Fe and your home use, all of that?
So that would, yeah, so you would, it's an average actually, an average use of what, through commercial and residential. I mean, we have...
It's not just the water you use in your home, it also includes city use of water on our behalf.
Right. So we've looked at those commercial, I mean, like I said, it's an average. So we've taken the amount of time that a person spends at their place of work and, we've averaged those things out versus the time that they've spent at home as well. So...
What's the ratio between commercial and residential?
Oh, I don't know that number. Commercial, like for example, the building, I work in the building across the street, the county, the administration building. And I think that we're using roughly, I have to think about it. I want to say it's like 10,000 gallons a month or something of that nature. But in the summer season, we have a lot of tourists that come in and use the bathroom, and they're there. We have several murals. So it does increase during that time, and then it'll decrease in the winter. So plus, we can also take into account, what we did was, I did an audit on that particular building. I hired a consultant to come in and kind of look at, what our habits are as, employees and those types of things. And, he said, well, how many females do you have? Because females, their water use is much more because they have to flush, and flushing uses 1.6 gallons, whereas a urinal uses about, it's 1.6 gallon per flush toilet. So, right. Each time. Mm-hmm. And then, but urinals only use like a half a gallon. So, he was saying, well, with a good idea of how many females to males we have, we know kind of what your habits are and those types of things. So those are some things that we considered. Okay, so here's some simple ideas. Like start simple and then we'll work our way up. So these are some things that you guys can do in your home. Basically, you can change the toilets and the shower heads to the ultra low flow ones. So that actually 1.6 gallons per flush is a low flow toilet. They do have dual flush toilets. So when you number one, you have you flush and then you push a button and it does a half gallon. And when you number two, you push another button and it's 1.6 gallons. So those are some things to think about. There you go. They have them in the new community conference center, whatever the old Sweeney building. So front-loading washing machines help reduce water. Basically, a front-loading washing machine uses about 7 gallons per load, whereas a conventional one can use, 7 to 13, and a conventional one uses somewhere around the neighborhood of 40 gallons per load, which is the top loading. So water your lawn or garden in the morning or the evening when temperatures are cooler and minimize evaporation. And don't let the water run while brushing your teeth or washing dishes. So those are really, really simple things. And it just has to do with like how we think about water. If we think of it as having a value, then we'll actually have respect for it and we'll treat it better. Like, so my thing is that at night, like I'll have a glass of water by my bed, but I don't drink all of it, But then I don't like to drink it in the morning either, so I put it on my plants. So it's just kind of little things like that. Or I don't know whose glass that was, but so it'll go on the plants. Those types of things. It doesn't go down the drain. Okay, so there's some water that can be recycled in our own homes. And gray water. Gray water is the water that comes from your bathtubs, your showers, and your washing machines, and not the kitchens, but not the kitchen sink. And black water is water from the septic tank. And then there's water from the sky. So those are things that we can use. So we don't want to use water from the kitchen sink because it might have like a bacteriological content, and then if we store it, it starts to smell funky, and eventually it basically becomes a septic tank. And you have to get permits and things like that for those. So for black water, which gray water is an easy one because you can actually hook up some pipe to your washing machine and have it discharged directly onto some of your plants and flowers and that type of stuff. And black water was water from the septic tank. There are people here in town that actually have found a way to utilize this water, and it's through series of tanks. So basically, things get kind of cleaner as they progress, and then it works out really well because it has a nutrient content for your plants. The thing is that you want to take an extra level of precaution, and if you're considering something like this, you just don't want to put it on edibles. So and then water from the sky, which we'll talk about in a minute for rainwater. And then we can learn from other countries. So for example, Australia has been in a huge drought for I think a couple years now. And what they've done is they have mandatory cisterns on all of their property, and I think they're in the neighborhood of like 1,000 gallons. So what happens is they collect the water from their roof when it rains, and then that water then is piped into their home, into their washing machine. So they wash their clothes with the rainwater. Then, when the rinse water goes out, it goes into their toilets. So then they're flushing the water. When they use the toilet, it's not potable water. It's not the water you would actually be drinking. And then it'll go to the septic or the sanitary sewer or something like that. So those are some things that we can look at from other countries. Hello. Okay, so rainwater harvesting is what it's called when you basically collect rainwater. And it's rain from the roof or, an artificial surface to put to beneficial use. So it's legal in New Mexico, and it does not use drinking water. Oh, it's a way to not use drinking water for our plants. So for example, the water that comes out of our tap is the water that we drink, those types of things. Well, the plants don't know the difference. Actually, they prefer rainwater because it's part of their natural system. And that way we can save our potable or drinkable or fresh water for our own consumption. And then it helps when saving groundwater and surface water withdrawals. And it saves with overall energy use from our water delivery systems. It is illegal to do it in other states. And it actually just, in Colorado, it just passed to where they can actually harvest rainwater, but they have to have some sort of a permit in place. And that, it was just went into effect July 1st. So Colorado, they couldn't do it. Yes, ma'am?
Why is it illegal?
Well, what they're thinking is that okay, so Colorado, a lot of the water that comes from the Rio Grande drainage basin, that belongs to New Mexico. It doesn't belong to Colorado. So it belongs to us, you know, the residents of New Mexico. So what they're thinking is that they actually don't own that water because it actually is supposed to come to us first because of compacts and things like that, some legal structures that were in place several years ago. And that's through the, have you heard of the Treaty of Guadalupe Hidalgo? Okay. So those are some things, huh? So anyway, and through the Rio Grande Compact, which is between Colorado, New Mexico, and Texas. So that's what their thinking was. But what they've found is that in a localized amount, a small amount of rainwater is actually more beneficial because you're infiltrating it on site. So you're helping your local area to absorb more water and actually percolate down into the groundwater and help their groundwater in a beneficial way. So they decided to go ahead and pass that law. And the law in New Mexico is, it has some gray areas, but basically because we can collect it on artificial surfaces. So for example, our roofed areas is an artificial surface that we've collected or we've created. And yes, sir? Because it belongs to... But it doesn't belong, what their theory is that it doesn't belong to the residents that live in that particular state. It belongs to downstream users. Anybody else? Why? I have a question. Why? No. Okay. So there are types of rainwater harvesting. The two types are passive and active. And passive utilizes earthworks to slow water, allowing it to infiltrate. So that infiltration thing is a big deal because we're finding out now that if we let water infiltrate in its natural setting, that it actually helps most of our ecosystem. So, and this is kind of an example. You could see all these little terraces that have been created to help slow the water and collect it in these little ponds. And then the little mini swales. So we're looking at kind of a map view, but in cross-section, you know, you would have sort of an earthen, berm that would collect water and help that tree out. And active systems utilize a pump to move water. Okay, so an active system, the components of an active system, which is why passive, we say simple is best, start with simple. So we want to start with our passive things first by, moving the dirt around and trying to create some things. And then we want to go to things like this, which is an active system. So the components of the system are a roof, obviously, for collection or a collection surface, some pipe, a tank or a cistern. And the pump is optional because it can do a gravity feed. So if we put it at a higher elevation, it'll actually, through gravity, the water will get to where it needs to go. Drip irrigation or water hose. So you can see in the top diagram how they've got their roof surface. They've got some gutters. Actually, I didn't put that in there, but gutters that go directly into their cistern. And then they've got some piping that goes to their trees. And then the picture below, that's actually the cistern at my house. And my cistern, in relation to the top picture, is at the very end. And because the way that my property is situated is that I wanted to have more of a play area for my little girl when she gets bigger. So I didn't want a big tank right there, when I looked out the window. And then I've got my, that box has the control panels for my drip irrigation system. And then it has a water hose attached to it. And then I have a pretty good sized garden, so that way I don't have to rely on I always have some fresh fruit, vegetables. But the other thing is that, we're talking about sustainability and sustainable water supplies, that my pump is actually is through P&M, through the local electricity. And eventually I'd like to get a solar panel so that way it's totally, it's sustainable in itself. Okay, so the future of water conservation. Basically, water conservation will become more of a mandatory requirement. Like this young lady said, that in California, their rates are pretty high, and I think that's going to be the norm. It'll be what's going to be happening throughout several states. The cost of water will likely increase over time, and it can increase the water supplies. Water conservation can increase the water supplies during times of drought. So that's why a lot of municipalities do put like mandatory no watering, those types of things. And there are opportunities for advancements in new technologies. So for example, like that, taking that tank and then it goes into the washing machine, and then the washing machine water goes into the toilet. So that's a pretty innovative, thinking. And we don't have anything like that here because so many departments and levels of government would need to get involved to make sure we have a comfort level. But on Australia's end is that they were in such dire straits that they needed this technology. And actually another story about Australia is that there have been, there's extreme pressure on the neighbors when, for example, if one neighbor is watering their lawn, they have, they can only water in the evening, that type of a thing. Well, apparently there was a guy that was watering his lawn not with potable water, so water from the water supply, not from his cistern. His neighbor went to the authorities and told on him, and the neighbor that was watering actually murdered his neighbor because of it. So you think that So because of little minor issues like this, we need to think ahead and not get to this point. So it's just like new technologies, and this is where you all come in. And the possibility of creating a new job market for future workers. And I think this is pretty much your future. This is what, you guys will be able to find definitely much more positions available for you all, is looking at water and what's happening to it and how to save it and the technology associated with it. So that's my last slide. And are there any questions? No? Yes, sir.
Did the neighbor murder him because he was stealing his water?
No, what happened was they were supposed to, they couldn't water at all from their faucet, which is their drinking water. And they only were supposed to water from the water that they collected from the rain. And he was watering from his drinking water supply. But that's about it that I know about that case. Yes, sir. Ma'am.
What about the water out in the county where when you use it, well water to water your plants, the soil turns white? That's not saline, but how much water has a lot of high minerals or trace minerals?
Yeah, that's a good question. So water quality issues, and we didn't touch, I thought about kind of going into water quality since that's more of my area. But yeah, so water quality and the cost of treating that water could be incorporated into those things, which will make our water much more expensive. So for example, the Buckman Direct Diversion, which is the water that we're going to get through the San Juan Chama River, there's a huge treatment plant that's associated with that, and they have some steep price tags associated with that. But the water that you're talking about where it turns white, that usually, like at my house, it has a high calcium content, and those are those minerals that have precipitated out. What else? There's a pop quiz for those of you who just came in late. I'm just kidding. Oh, I don't know about the, I mean, there are things like microclimates that you can create. And like, let's see if we can, whoops. So like on different sides of the house, you know, they've got their north arrow. On different sides of the house, you know, that it's sunnier or colder on one side. So you can create sort of those microclimates, and where water will, like I have one side of my house where the water, if it rains, the soil stays moist for a while, and on others it evaporates. So it could be that they're toying with those types of things like microclimates. And it's very, you know, that's sort of the way that we're moving to, is into the microclimates and sort of restoration issues, those types of things too. Yes, ma'am. Well, rooftop gardens help with stormwater management. So these are runoff issues that that basically the EPA has mandated that we need to manage our artificial surfaces kind of, and we need to mitigate that stormwater that's happening. And through roof gardens in places where they have a lot of precipitation, especially the East Coast, they've looked at that as a way to manage their stormwater on site instead of it running off or running into gutters and things like that. And in Seattle, it's a big, that's actually pretty popular as well, because the water from their stormwater has gone into the local estuaries and the bays, and I believe it's their salmon population has really suffered because of all those, the oils and things like that are in the water now.
Would it make any difference to have rooftop gardens in a place like Santa Fe?
Like climate change wise or stormwater management wise?
In terms of more moisture?
Well, it wouldn't, like as a microclimate, I think that we're gonna get pretty much all the precipitation that we're going to get is around that 14 inches. Yes, we do get more in places like Tesuque than where I live off of Highway 14. So, and that has to do with, again, that's a microclimate as well. And it has to do with our proximity to the Sangre de Cristo Mountain. So Tesuque, obviously, they're higher up in elevation, so they're going to get more snow and rain. I don't think that they're going to, they might help with the heat island effect, so that's when things reflect off. And create a little bit more heat. So it might lead to a trend in the overall regional cooling, but not on a large scale. Maybe just throughout the city it might be cooler. I'm sorry? I think it would probably have I think it would work better. My personal, Laurie Trevizo, personally believes that Albuquerque is a better candidate than Santa Fe is, and it has to do with our short growing season, freeze thaw, those types of things. But Albuquerque would be a much better candidate for those types of things. Any more questions?
Well, if not, let's thank Laurie for a lovely presentation.
Yay!
Before you leave, just a couple things. First of all, please just look around you and make sure to take your personal